Hey, wait till you see this. Alright, let's recap. Um, SCR driver board. Basically taking the H11D1. Oh, let me sit down here. H11D1. And driving it with just a. Oops, I forgot to fix frequency. A CMOS signal, which is just unipolar square wave at 5 hertz. So we're dealing with 120 from the non-isolated variac, 100, 120, but I've got it on 0, as I'll show you in a minute here. Anyway, and we rectify that, and that gives us the unipolar, the classic unipolar DC, which I can't show you at the moment because my probe's on the cell and stuff. But anyway, you get the typical unipolar non-filtered DC, and it's at 60 hertz. So with the original 8XA design, that was apparently what was being used. And so I rigged this up. Funny thing about the H11D1 is it's a photo transistor. It's an opto transistor, whatever they call it, and that means that the diode can influence the base, but the opto has an extra pin for the base of the receiving transistor, and that base can be biased, or at least would think it needs to be biased. However, I've removed my biasing for the moment, so it's not hooked up, so there's no connection on 6 there. Anyway, 8K resistor from the specs on the H11D1 is the max current that it can handle across its collector emitter current on the opto is 60 milliamps max, whereas the SCR back there is a BT151, I think, and it will its characteristics say max 100 milliamp for its the gate. Yeah. So the 8K resistor that you see there, it's a 2 watt or 4 watt, I think. It's a big bastard. 4 watt. Will give me at 120 volts max. Will give me cap it right at 15 milliamps. So I presumed that was correct. Anyway, the SCR is not working properly. It's not switching. As soon as the variac voltage gets anything above 10 volts, it shuts off, and that's the interesting thing that I'll show you. So anyway, I've used my Decade box here in parallel with that 8K, and I'm running a 9K here at the moment just to cut it all the way off. So 7K approximately net parallel resistance is still too high for the bias, but as I turn it down, an interesting thing starts to happen. So now note, we have no voltage across the cell. The differential isolated probe is measuring the output of the choke on the cell. The choke is in I think it's in phase. I'll have to plot this out later as I test it, but it was just interesting that debugging this led to a discovery over here, as you shall see. So I'm going to slowly bring the 9K down here to 8K, so that should net me approximately 4K in parallel here. And as I bring it down, interesting thing starts to happen. The SCR, I gotta get a little further down. So right at 4K now, or 3K maybe. There it comes, wait a minute. So usually right about 3K we start to see a little bit of a spike. When I come down to 2K, and what starts to happen, the SCR starts to it starts to switch. Now this is on the 50 scale, 250 millivolts, so it's like just tiny little bit of signal going to the cell right now. But I'm going to come down here to 2, and you see what starts to happen. We start to see the SCR working, and we're getting the gated pulse. You know what? There's just a little bit of a rise to it. Now we're going to go down to 0, and I have a 200 also on here just for bypass in case so I don't dead short. But when I go to the 200, you see it still has no effect on it. Even dead short doesn't until I start to bring the variac up. And watch what happens when I bring the variac up. Just a hair. It's still on 4 or 5 volts maybe. Anyway, what starts to happen is step charge manifests. Step charge manifests. Now, that's the 60 hertz frequency. But, as you can see, it's a very nice looking step charge. Look at that. So, the interesting thing is, when we turn it on, we start to finally get a little bit of power to the cell. Now, mind you, where I do that, we're using 0.14 amps, so almost 4 watts, and they got a really low power factor right now. I'm still trying to figure out why that is, but 0.14 amps. Anyway, I just start to bring it up. It's all the way down now, so you now bring it up, and just to where we get a little bit of vibration out of the choke, and you hear the 60 hertz hum. But look what happened. Look what happened. Where did the step charge go? As soon as that transformer started humming and started trying to pull its cores together, the step charge died and current started flowing. I back the variac back down a little bit to where the transformer can't pull itself as close together. We even hear a little bit of a, you can hear it. No activity. Oh, wait a minute. I spoke too soon. Yeah, so there's a little bit of bubbles there. It's interesting because my voltmeter, I'm trying to read DC. This is, oh, wait a minute. Did a clip come off? No, yeah. So I'm not hardly seeing any DC voltage on the cell. There's, looks to be like a step charging AC voltage. It's quite interesting. But anyway, we get some reaction out of the cell. Not very much, but remember, I ain't got nothing here. So when I go up and the frequency dies now, yeah, we get more reaction, potentially. And I crank it up pretty high here. Well, to 13. And yeah, reaction increases. But we have no step charge anymore. Oops, there we go. So where did our step charge go? Now we're using 0.16 amps. I'll bring the variac up a little more. We totally don't have our step charge, but it still works. Presumably because it's just rectifying DC and acting like a resistor now. And the current slowly climbs as a little more I give it. And mind you, I'm still on, now I'm up to like 15 volts. Who knows what actual voltage that is, but I had to move the kilowatt before the variac because it wouldn't power up until you get to 90 volts, which wouldn't be good. So anyway, let's get back down to recap here. Our step charge is here, and now we see an interesting voltage on the cell. The voltage is still there. Give it a little bit of current, and I think I got my leads backwards. And it brought up the charge, and now the step charge pulse can retain it. So can we go and, nope, it died again there. So that holds us, let's say we hold it at 3 volts, take it back down to right there where the step charge occurs. Yep, back it up. Right there. And we see the 5 hertz pulses. So let's see what happens if we try to mess with the gate while this is occurring. Oops, I think I bumped it. Yep. Alright. So now we're going to mess with the gate. I can't get this all in one picture. I'm going to go up to 6 hertz, 7, 8, 9, 10. Pulse got a little shorter. Let's see what happens when we just try to put some much higher frequency into it. Start to see out of the wave. The wave starts doing shit. Isn't that weird? Why is the wave doing shit? That was 60 hertz. We're hitting multiples, so now I'm up to 90. Is that 90? Yeah, so 90 we can start to see a little bit of a stepping going on. Let's take it up to 120. That should be what, 1/2 wavelength? And 180 would be 3/4, not seeing much there. Let's step it up much bigger, so like 1K. Not seeing a whole lot of change in the waveform. Let's back the voltage off. We still not retain our step charge. I give it more current. Voltage climbs a little, but we lose the reaction. So the gate, way too high for the gate. Let's go back to, damn it. Go back to like 6 hertz or 5 hertz here. We started. Yeah, I'll go 10. Alright, bring it back up. You see what's happening here. Whoops, too much. So what happens? We got a step charge. Watch the step charge. I'm going to squeeze this together. Notice what's in between bubblegum wrappers. So I'm going to squeeze them together and look what happens. Where'd the step charge go? I'm going to slowly let them back apart. There's that phantom step charge. Squeeze. Open. Closed. Open. Closed. Open. Closed. I'm just squeezing it lightly here, just enough to bring it a hair closer together, and that's why it dies as soon as we give it some current, because when you hear the hum there, the ferrite core has effectively pulled itself closer together enough to kill this reaction that's occurring, producing the step charge, and current begins to flow in the dead short condition. However, we can prevent that current from flowing at the moment by reducing our input voltage. We do see characteristics of step charging in the choke. So there's something special through the gap. Something special. Stay tuned.